Hello children, so this is Karthik, physics faculty from Perfect Academy. In the last sessions, we dealt with the few concepts of magnetic effects of current. Now here we are going to deal with the last and very important topic, that is moving coil galvanometer. Moving coil galvanometer. So what is the main principle of this moving coil galvanometer? Actually, galvanometer is nothing but a sensitive device which could be calibrated conveniently to measure the current as an ammeter, to measure the voltage as a voltmeter. And now, what is the main principle of working of this? That is nothing but whenever a current carrying coil is suspended inside the magnetic field, then it will have a torque. Due to the torque it is experiencing, it will have some rotational twist. Now let us suppose C is going to be the torsional constant of the wire. With the help of what we have suspended the loop, and if theta is the amount of deflection, then according to our known principles, C into theta is going to be equals to BIAN, and from here what we can write, I by theta equals to C by BAN, or in other words, I equals to, I can write like a K into theta, where K is nothing but C divided by BAN, which could be called as a galvanometer constant, or it is also called as a figure of merit. It has another name, that is figure of merit. Now regarding this galvanometer, we have to define two important terms. What are they? They are nothing but current sensitivity and voltage sensitivity. Let us see both of them. Current sensitivity. What is the meaning of current sensitivity? It is nothing but theta divided by I, the amount of current required to have a unit deflection. The amount of current required to have a unit deflection. From here, what is the theta by I? That can be written as a BAN divided by C. This is going to be the current sensitivity. And what is the unit for it? The unit for it is nothing but division per ampere. If I measure the current in ampere, and if theta is nothing but what? Angle, what we are generally writing as a divisions, number of divisions. Therefore, IS is nothing but divisions per ampere. This is the current sensitivity. And the next term we have to define is the voltage sensitivity. Voltage sensitivity. Voltage sensitivity is nothing but Vs. That could be written as theta divided by V. So, which can be measured with the unit called divisions per volt, and this can be also written as theta divided by I into G, where G is nothing but the resistance of a galvanometer. The resistance of a galvanometer, let me represent with the letter capital G, and I is nothing but current going through the galvanometer, or sometimes I can also write like a Ig. This Ig and I both are same only. Therefore, theta by I is nothing but what? Current sensitivity. So current sensitivity divided by capital G. What is the current sensitivity? BAN divided by C into G. This is called as a voltage sensitivity. Now, based on this concept, let us do one small problem to understand that concept. Well, so here I have the problem. It is given like this. It is given like this. They have given that there is one galvanometer whose resistance is 95 ohms, and it is shunted parallelly with the 5 ohm resistance. Now this whole system is connected to 20 kilo ohm series resistance, and this galvanometer is having a 50 divisions. Now let us suppose it is connected across the 2 volt cell. This galvanometer is having a maximum of 50 divisions. It is having maximum of 50 divisions. We have to find out what is its current sensitivity. And now let us try to find out what is the current going in the circuit. From that we could able to calculate what is the current sensitivity. So here it is 5 ohm, it is a 95 ohm. What could be the effective value of these two? That will be definitely less than the 5 ohm. When the two resistors are connected in parallel, the effective resistance will be less than the smallest value of the both. Now here 95, here it is 5. The effective value will be less than 5, which is very small compared to 20 kilo ohm resistance. So that I can ignore this small value. Hence, what is going to be the resistance in the circuit now? 20 kilo ohm. What is the voltage? 2 volt. Therefore, the current flowing in the circuit is nothing but 2 volt divided by 20 kilo ohm. and therefore what we can write, 0.1 milliampere. 0.1 milliampere. This is going to be the current flowing in the circuit. What is the maximum number of divisions? 50 divisions. Therefore, the current sensitivity is nothing but what? Maximum number of divisions divided by the current. That's going to be equals to 50 divided by 0.1 milliamperes, division per milliamperes. So it can be written in two ways. What are they? 500 divisions per milliampere or 0.5 divisions per microampere. Either of the units you can use. 50 divisions per milliampere or 0.5 divisions per microampere. This is how the current sensitivity has to be calculated. Now let us know how to convert the galvanometer, the sensitive galvanometer, into the ammeter. What is the meaning of ammeter? Ammeter is nothing but a current measuring device. The ideal ammeter should have a zero resistance, and so in real life we will not get an ideal resistance. So what we will do is we will make this galvanometer to have a as much as possible least value of resistance. And here itself I told you one point. What is it? Whenever small resistance is connected in the circuit, I mean for any resistor in parallel, then the effective value of this total will be less than the smallest value. Therefore, the same principle we are going to apply here now. So how to conversion of, let me write here, conversion of galvanometer into ammeter. Conversion of galvanometer into ammeter. That's what we are going to see now. Well, so the galvanometer can be conveniently converted into ammeter by connecting a suitable parallel shunt resistance. Let me call this is the shunt resistance, and this is going to be the galvanometer whose resistance is capital G. Now this whole system will be served as a ammeter, and this is what we are connecting in the circuit in series across any components, so that we can able to find out what is the current flowing in that part. So here it is nothing but ammeter, and now see this one. Let us suppose the current entering into this ammeter is I. Now that will be conveniently split up into two parts. What is that? Ig, and remaining part is like I minus Ig. I minus Ij. Since these two are connected in parallel, the voltage across this and the voltage across this part must be same. Hence what I can write, Ig into capital G equals to I minus Ig into S. Now from here, what is the formula for shunt resistance? Ig into capital G divided by I minus Ig. Let me take this Ig to the denominator. What I'll get? G divided by I by Ig minus 1. Now this I by Ig is factor what will denote with the N. So the shunt resistance to be connect is nothing but what? G divided by N minus 1. And here I told N, that is nothing but I by Ig. That can be understood like this, I by Ig. It has another meaning, that is the new range divided by old range. What is the meaning of this range? For example, if I take one ammeter which can able to measure from 0 to 10 amperes, its range is nothing but 10 amperes. If I take one ammeter which can able to measure from 0 to 100 amperes, its range is nothing but 100 amperes. So that's what called as a range. Range is nothing but maximum minus minimum. That is called as a range. So this N could be defined as what? I by Ig. That has another meaning, new range divided by the old range. And very good. And now let us see one small problem on this concept, so that we will betterly understand what so far we have understood. Let us go with the problem now. So here I have a problem. Let me state the problem first, and then we will understand. So here I have a problem like this, a galvanometer resistance of 50 ohms and its full scale deflection current is 50 microampere. Right, so here is the question. Let us understand the question first and then we will do the solvation. Let us look into here. What they have given? A galvanometer that has a resistance of 50 ohms. So what they have given? Capital G they have mentioned for us. So let us go with the solution. The galvanometer has a resistance of 50 ohms. So capital G is given as a 50 ohms. It has a full scale deflection current as a 50 microamperes. What is the meaning of full scale deflection current? That is nothing but Ig, which could be equals to 50 microamperes. What is the shunt resistance that should be added so that the ammeter can have a range of 5 milliamperes? Therefore, that problem we can do like this. What is the shunt resistance to be connected in the circuit? That is given by the formula G by N minus 1. And what is this N? What is this N? I divided by Ig minus 1. So that I is given as a 5 milliamperes and Ig is mentioned as a 50 microamperes and capital G is already given with us. Simplification of this, that's all. So 50 ohms divided by I is nothing but 5 into 10 to the power of minus 3 divided by 50 into 10 to the power of minus 6 minus 1, and this is going to be gives you 50 divided by 100 minus 1. So 50 by 99 ohms. So here 10 power minus 3, here 10 power minus 3, and we will get with the 10 power minus 2, that will go to numerator 100 minus 1. So 50 by 99 ohms. In this way we can do this sum. Let us move for another sum to understand this. Here we have the next sum. What is that is? What is the value of shunt resistance that passes 10% of the main current through galvanometer of 99 ohms. They have given the galvanometer resistance as a 99 ohms. Let us try to solve this one. So here they have given what is the shunt resistance that has to be connected. So that the 10% of main current, what is the meaning of main current? I. The 10% of main current means 10 by 100 of I. That must pass through the galvanometer. This is nothing but what? Ig. From here what we can say? I divided by Ig is nothing but 10. We already have the formula for shunt resistance which has to be connected in the circuit, which is nothing but G by I by Ig minus 1, and this can be written as a 99 divided by 10 minus 1, that equals to 11 ohms. This is the resistance, shunt resistance. We have to connect across so that it will have a current through the galvanometer. 10% of main current will go through. Well, so let us move for the next problem. So here is the next sum. What is that is? A galvanometer has resistance 500 ohms. It is shunted so that its sensitivity so this is what we have to do now. So a galvanometer has a resistance, let us do this problem. A galvanometer has a resistance of 500 ohms. So it is shunted so that the sensitivity is decreases by 100 times. Actually, for an galvanometer which has to be converted into ammeter, the sensitivity and the range both will be inversely proportional to each other. If the range is more, sensitivity will be less. If the sensitivity is less, range is more. So here the sensitivity is decreases by 100 times. That means the range will be increases by 100 times. The range will be increases by 100 times. Therefore, we already seen this formula. N is nothing but the new range divided by old range. What is this ratio? It is 100 times. Therefore, what I have given with I by Ig is nothing but what? 100. We have seen already that formula. The same thing we are going to substitute back now. So what is the shunt resistance to be connected? G divided by N minus 1. That N is nothing but new range divided by old range. According to the given question, the range will be increases by 100 times. Therefore, I by Ig, this N is nothing but 100. That's what we are going to substitute back. What is capital G? The capital G value they have given as in 500 ohms divided by 100 minus 1. So 500 divided by 99 ohms. This is the shunt resistance we have to connect across so that the sensitivity will be decreases by 100 times or the range will be increases by 100 times. And with this background, let us step into the next concept, that is how to convert the galvanometer into voltmeter. The conversion of galvanometer into voltmeter. Let us look into this. So a galvanometer will be conveniently converted into voltmeter by connecting one series resistance to it. So let us suppose it is a series resistance, what we are calling as a capital R, and here I have a galvanometer which are connected in series. Now this whole arrangement will serve as a voltmeter. When we connect this component across any part, in parallel with the circuit, then we will have a measurement of voltage. So it is series resistance, it is a galvanometer resistance. Let us suppose a current I is entering in the circuit, entering into this part. Then what we can write? I will be equals to the V can be written as a I into R plus Ig into capital G. Right, now further V minus Ig into capital G can be written as a I into R. R, in other words, what is going to be R? R is nothing but what? V divided by I minus Ig into capital G divided by I. So this is nothing but what? V divided by I minus G equals to minus 1. Okay. This I would like to make a small change here. See this one. V minus Ig equals to I into R. Therefore, This can be changed into R equals to G times of V by Vg minus 1, where R is nothing but G into N minus 1. Again, this N is nothing but what? V divided by Vg is nothing but what? The new range divided by old range. This is going to be the formula for N. So let me repeat again. So V equals to IR plus IgG, then V minus Ig equals to I into R. So from where G can be taken as a common out, so that V by Vg minus 1 is going to be equals to R. And so N R is nothing but what? G into N minus 1, where N is nothing but new range divided by old range. This is the formula. So let us do one problem to understand this concept. So here we have the problem. What is that is? Let me write here. A galvanometer has a resistance of 50 ohms and right. So here is the next problem. Okay, here is the next problem. A maximum current of 0.5 milliamperes can pass through a galvanometer having the resistance of 20 ohms. So that maximum current is nothing but Ig 0.5 milliamperes, and the resistance they have given as a 20 ohms. Therefore, what's going to be the voltage, maximum voltage? Vg given as a 0.5 into 10 to the power of minus 3 multiplied by that 20. So which will give you the result? 25 is 100. So 10 into 10 to the power of minus 3 volts. So which will be given as a 0.01 volt. So 10 power minus 2. So 1 by 100. 0.01 volt. So VG value they have given. Now how much resistance is to be connected in series to convert into voltmeter of range 0 to 5 volt. That means V they have given as a 5 volt. VG already it's given to me. Therefore, what's the formula I have? N I have to find out first. N is nothing but what? V divided by the VG. Here I have written V divided by VG. V is nothing but 5 divided by 0.01. So this will gives you 500. Now what is the series resistance you have to connect? G times of N minus 1. What's the G value? G value is given as a 20 ohms multiplied by 499. So which will gives you 189980 ohms. This is going to be the series resistance that has to be connected across it. And so in next section we will go with the continuation of these problems. Thank you.